Hi guys, in this video I want to look at the map which represents a small visualization of the play area of the entire game. As you can see, it shows where the plane is within the scene, and there's a semi-transparent background so we can still see what's behind this map. We have our line of representing the terrain with objects sitting on it, and if the enemy attacks them and drains energy, this will be reflected in that mini-map. Looking at the scene, we can see that it is based on a color rectangle. I've called it map, and then it has child nodes of a line 2D for the terrain, then a 2D node for the structures, and then a 2D node for the enemies. And we've got an attached script. So we see it extends color rectangle, and we've given it a class name of map and some constants. The scale will be how smaller the structure objects are made, so there'll be a quarter of the size. There'll be about 4 pixels wide. And then this item scale is a vector 2, which we can multiply. And our variables, we've got a coordinate scale which will be calculated based on the size of the viewport. And when the viewport is scaled or resized, then this will be re-evaluated. And line is a reference to the line 2D, and structures is going to be used to reference the structures node, and enemies referencing the enemy node, and player will be referencing the player, and then the plane is referencing the sprite of the player. So when the ready function is called, we just get references to these 3 nodes. And I mentioned the resizing. In the main script, we connect a signal from the engine called size change to this function called resize. As that's being run, it gets to map.resize, so it calls the resize function on the map. So when the map.resize function is called, it passes in the terrain object and size y, which is the viewport size in the vertical direction. So going back to the map script. So when the resize function is called, we calculate the coordinate scale by dividing the rectangle size of our color rectangle by a vector 2, and the x component is calculated from the number of points in the terrain times the terrain's grid size. And then the height is the viewport's height, this y size value. And then we work out the line position for the terrain in the map, and that will be pinned to the left side of the rectangle, so x is 0, and then the y coordinate of it will be the terrain's base level times the coordinate scale y value. And with that line positioned, we then set the points for the terrain in the map. So this SetPoints function takes in the terrain, and we first of all clear any existing points that we may have manually added to this line to test it out. And then we loop through all the points of the terrain. This is the terrain line get point count, so we go I equals 0 to this value -1, and we go line add point, and then the terrain point at that place, so we go terrain dot line dot points I times coordinate scale, and then add that point to our maps line. And then from the main function, we will call when we start the game, we get our structures, and then we call map add structures, and this is the add structures function. In this add structures function, we don't care about fixing the position in this function. We'll do it later. So we will loop through the global structures values. Let's remind ourselves what the structure scene looks like. We have a kinematic body 2D at the top, and then we just want to get to the sprite for this image. So we go node, get node sprite, and then make a duplicate of it. Here we're going to reference the main node by getting its instance ID as a string, and setting the node's name to it. And we want to rescale the size of the sprite, so we go, the scale is this item scale constant that we defined earlier up here. making it a quarter of the size. So now we have this node value, we add it as a child to the structures node. Going back to the main script, the next thing we do is add the player. We pass in the player's reference and the scroll position that we are in, and the terrain object. This is the add player code. For our player in the map, we make a duplicate of the player that was passed in, and we remove its collision shape 2D, which we see there. This will stop it responding to collisions with objects passing through the map. And we call this position player function, passing in the player value from here and the scroll position on the terrain object. So this is the position player function. The max X value is the last horizontal position in the terrain. For the player sprite scale, we'll use this item scale value, but make it half the size, otherwise the plane looks a bit too big. So now let's calculate the X coordinate for the plane, and it'll be max X minus the scroll position plus the X position of the plane in the game. And if X exceeds the maximum value of X, we want to wrap it round to the left side, so we go X minus max X to get the offset from the left side of the map. And then if we've gone off the left side, X is less than 0, we go X equals max X minus this X value to position it to the right side of the map. And then set the player position, which is a vector 2 of this value of X, and then position Y, and then times it by the coordinate scale to scale it down to the map dimensions. Looking back at the main script, I've added an enemy for testing here, and this is a function to do that. And we make our enemy and give it a target and a position to start from, and we add it to the terrain. And then we've added to our globals to the enemies dictionary, and we call add enemy on the map. Here is the add enemy function. We get the sprite from the enemy and then set that to this node value, then give it a name like we did before with structures. We get the instance ID of that node and assign it to the name of this node. And the scale is the item scale again. And we add this node as a child to the enemies node. So when the game is running, the process delta function is called on every frame, and we need to update our map with the position of the player and update all the entities for the changes in scroll position. So we just looked at the position player function. Now let's look at the update all entities function. This calls update entities twice, first with the structures and then with the enemies. Here's update entities. We pass in which group of entities we want to update on the scroll position. So we loop through them, getting the children from either the structures node or the enemies node, and we get the ID from the name. Now we want to check if the entity is still in existence in the game, so we examine the globals property, which is called enemies or structures, and we get its keys. And if the ID exists in the keys, then we know this entity is still in the game. We go globals get to access the property, the structures or the enemies, and index it with this ID value that gives us our node. And to set the position of the entity, we call the function getNodePosition, and this function is here. We pass in the node and the scroll offset value, and we calculate the return value by going node global position times the coordinate scale to scale it to the map scale, then add a vector to give us our offset. This is calculated from the rectangle's horizontal width. Take off this offset, but times that by the coordinate scale of x, and add nothing for the y value. So we set our entity's position to the return value from getNodePosition. And then we want to make sure the color is tracking the color of the entity in the scene. So if an enemy goes to drain energy from one of the structures, the color of that structure will be changing from green down to red and then back as it charges up. So we want to track its modulate value. And if we found the entity was no longer in existence, we want to free the one in the map, so we go e.qFree. So that's updating the entities. So finally, if the player turns, then the plane in the map should also turn. So we have a turn player function that simply flips the plane's sprite. So we go plane flip h equals not plane flip h, which just flips the Boolean value between true and false. Looking at the main script, you can see that in the turn player function we've added a call to the map's turn player function. If we look at the map scene, you can see the color rectangle's color has been set to be almost black, then the alpha value is set halfway, so it's semi-transparent. So that's it for this introduction to the map, and I hope to see you in another video. Goodbye.